Hello, fellow solvers. This is Cog with Cog Analytics, and today we're diving into day 2 of Advent of Code. Now, this is another simple problem, but it will require a little bit more thought to achieve the solution as compared to day 1. We can see that our input is a list of sequences of numbers where each sequence is referred to as a report, and each value in the sequence, like the number 6, for example, is referred to as a level. Now, the point of the question is to identify which reports are considered safe. And to be safe, a report must be either strictly increasing or decreasing by a magnitude of between 1 and 3. And so we can see in this first sample case, in the 6421 report, we have a safe report because all levels are decreasing by 1 or 2. On the other hand, in the second to last example, we have a duplicate of 4s here, which is neither increasing nor decreasing because the delta is 0, and so this report is considered unsafe. And again, the question is how many reports in our input are safe? In part 2, we have an added twist that we are allowed to tolerate a single bad level. In other words, before we check for safety, have the freedom to remove a single level from a report, and then we can check for safety. The question then becomes, how many reports with this added degree of freedom would now be considered safe? As we approach this problem, first, let's frame it. An easy way to do that is with sample data as we just examined. So in this case, we have 4 level reports, 1, 2, 5, 7, and this bottom one, 8, 6, 3, 2. The question is, how do we solve this in Alteryx? How can we approach this problem in Alteryx, which is primarily a tabular data tool? And so thinking about this as a table, if we imagine each value or each level in a report as an individual record, then the approach becomes, one approach is to go from record to record and analyze the difference between records, ensuring that the magnitude is within range and that the sign of the magnitudes is consistent for the entire report. In this case, all of the magnitudes 1, 3, and 2 are within the range 1 to 3, and all of them are positive. So this is a strictly increasing but safe report. Similarly, this is a strictly decreasing but safe report because all of the magnitudes are the same and the sign is the same for all of them. Now, anybody that is an Alteryx expert or has experience with Alteryx should immediately know which tool we are leaning towards at this point, and that is the multi-row formula tool, because we are looking at record by record differences and iterating through the entire data set. Now, the next question then becomes, how do we configure the multi-row formula tool to be able to actually compute this information and provide the desired output of whether or not a report is safe? One way to do that, and here we have looking again at that following example or the previous example, one way we can do that is to create a new field which tracks whether the report is increasing and safe, decreasing and safe, or unsafe. And in order to do that, as always, we start with the first record in the data set, and we're going to assume that what we have is a safe sequence. And we can begin that by just assuming or providing an output of null. On the next iteration, we're going to check the difference between the current and the prior levels to ensure that we have a good magnitude, which we do in this case, 1. And so we assign an output of 1. So now we are assuming the direction is positive, and thus this is an increasing safe sequence. In the next case, 5 minus 2 is 3, so that is an appropriate magnitude, and we have the same direction as previously. This is positive, and we're working with an increasing safe sequence. And so we will again assign a value of 1. And then in the end, we do the same thing. We have a good magnitude. It's in the same direction. So the output is 1. And we can conclude at the end of this process that we are working with a safe sequence, which is strictly increasing. So that's all fine and dandy. But what happens if we have an unsafe report? We have 2 more examples here. In this case, we can see 1157 that there's a duplicate of 1s, which is a magnitude or a delta of 0, so this would be considered unsafe. Similarly, in the bottom here, we have a magnitude of 4 and negative. So because this magnitude is too large, this would be considered unsafe. Similarly, we have a change in direction, so this is neither strictly increasing nor decreasing, so this would be doubly unsafe. the question is, does our current process handle these cases? And we can run the first example through this process. We assume we have a safe sequence, which is, so we start with null as our output. The next iteration, we look at the second value. The delta is 0, which is a bad magnitude, and so we can immediately assign a value of 0. This is an unsafe sequence or an unsafe report, and then that will propagate down all the way until the end, allowing us to conclude that this report is unsafe. In part 2, we have two ways that we can approach it. Either we can utilize the algorithm that we just developed and brute force it, applying this to every possible subsequence generated by removing a single element, evaluating for safety. In most cases in Advent of Code, this is not a good idea. But again, because this is an early problem, and because of the simplicity of this problem, this is actually still a viable strategy. I will leave this up to you to check if you'd so like, and if you want to do this, I would encourage you and point you to the Generate Rows tool as a good way for generating all of the cases for this problem. Alternatively, and the way that we're going to approach this is to identify the three primary cases, which are the only things that we actually need to check. This is a more optimized approach and saves us some computation and processing time. Now, how do we do this? What cases are we looking at? So we'll look at these three examples, and these are all the cases. So in this case, we have the first one, 3, 0, 1, 2, 3. If we begin our process, we start with the number 3, assuming we have a safe sequence or safe report. We look at 0, so now it's decreasing. The difference is -3. And then we go to a 1. So now the delta is positive. So this point, this value fails our process. So we designated that with this red circle here. And by the end of our process, this final output should be a 0, indicating we have an unsafe report. Similarly, in the second example, we have an increasing sequence that then decreases at the value 2. And so at this point, we have an unsafe report. And so we've designated that again. And then finally, 0, 1, 2, 3. And then we have a magnitude difference of 6, which is too large. And so this 9 here is the value where the process is broken. And we have our first place where we've designated an unsafe report. Now, even though these red circles are the first place where our process breaks, these are not the elements necessarily that would need to be removed to create a safe report. However, it is these elements with the red arrows that you can see that designate which elements need to be removed to generate a safe report. In this case, the 3, the 4, and the 9. Now, the three cases that I'm going to posit to you without proof that contain all possible cases that need to be checked. Either the first element is corrupted and once removed generates a safe report. The element before the failure point in our process, and so in this case the 4, or the element itself that fails our process. If those three are removed and a safe report is generated in any one of those cases, then we have what would be considered a safe report. Otherwise, the report is unsafe still. And I will leave that to you to prove. Again, should you be interested. Jumping into Alteryx, we now have everything that we need. We've framed the problem and have a good understanding and grasp of what we need to achieve. And this right here is all that we need in order to actually do the report check and identify whether a report is safe or unsafe. We can see here in our get direction multi-row formula tool, the exact process that we just described. So if a value is null, assign null. So this is the first record check. If we're working with an unsafe report, then propagate that value 0 through to the end. And otherwise, we're checking for the direction and magnitude, and again, setting that appropriately. We then sort the data and summarize, looking at the very last item in this process for each report. And that tells us whether a report is safe, strictly increasing or decreasing, or in the case of zeros, unsafe. And so you can see here are the two examples that we already looked at. The first two are considered safe, and the last two are unsafe. That's it. We can plug that into our actual input data. We begin with this list of strings. We can parse through that. First, of course, we must index our data. We can do that with the record ID tool and add a report ID. Then we can tokenize or use the text to columns tool to parse through and tokenize there, or split to rows. Now we have all of our levels. We can add another ID so that we can keep track of those levels. And then we run that report check that we just described for part 1 on all of the data to identify which reports are considered safe, filter out those that are unsafe, count the records, and that gives us our answer. In part 2, as we already described, we first want to find the point at which we have the first failure in our process so that we can then either remove the prior element, the current element, or the very first element in every report. Once we do that, we copy paste the exact same process to check those sub-reports. And once that's done, we can union the data back together, filter off any that are unsafe, and everything that's left, all we need to do is count distinct on those report IDs that we got at the very beginning or assigned at the very beginning to identify, again, our output, which is with this extra degree of freedom, how many reports are now considered safe. I hope it has been apparent how powerful it is to frame the problem beforehand and conceptualize how you're going to approach the solution in Alteryx before you start throwing tools down on the canvas. Sometimes it can be nice to throw something down and just kind of play with the data, but other times, especially as the problems get more complex, it will be beneficial for us to plan out our approach a little bit beforehand. Anyways, please like, subscribe, comment. Again, if you have any other solutions or your approach was different. There are a lot of very unique and interesting approaches in the Alteryx community. I'll leave a link to that in the description for this problem. As always, I hope this helps, and happy solving.